R Thevenin should be 11 over 3. Okay, 11 over 3 ohms. And then from this, because you know what VOC should be, okay, R Thevenin is also equal to V Thevenin over I Norton, or V open circuit over I short circuit. And then this is 3, this is I Norton, and then you would have that I Norton must be equal to 3 over RT, which is 3 times 3 over 11, which is 9 over 11. Okay, this is I Norton. I Norton must be 9 over 11 amps. So you work this backward, okay? It's just a test current method, test signal method to solve this problem. And then there is the other part that asks you for the available power of this circuit. So we have this equivalent circuit, which is 3 volts, and then you have R Thevenin, which is equal to 11 over 3 ohms. And then in order to get maximum power transfer, you have RL must be 11 over 3 ohms. Okay, that's called circuit matching. Then you can figure out the voltage. Okay, this voltage must be equal to 3 over 2 volts. And then the current is equal to 3 divided by 22 over 3. You sum these two resistors up, the voltage divided by that resistor gives you the current, and then P is IV is 3 over 2 times, let me see if I do this correctly, 9 over 22, right? 27 over 44. Bingo, I got it correct.
That's
So,
why you're the teacher.
What?
That's why you're the teacher.
Yes, yes. So it's 27 over 44. And then part B, yes.
Why is it B equals to minus 2ix plus 3?
B, which line are you referring to? This line?
Yeah.
B is equal to 2ix plus 3. That goes from here, right? Oh, that goes from this figure. Okay? This voltage, if I write the peak-off voltage law in this loop, okay, this voltage must be equal to this voltage plus this voltage. Okay, what is this voltage? This voltage is equal to, if I write 2Ix is the voltage drop in this direction, but I want to write it as a voltage rise. So I put a minus sign in front of it to make it minus 2Ix. And then the other one gives me a voltage rise. Okay? So this gives me a voltage rise if I use this 1 amp, so it's a plus 3. So you have to make this, both of them into a voltage rise. This voltage is equal to this voltage rise plus this voltage rise. Because this is a voltage drop. Okay? So you have that and that, and then you work through them, you get those as your answer.
Wait, how is the 3 voltage rise if you're going into the negative terminal of resistance? Or of the,
You mean this 3 voltage rise?
yeah, why is that positive? Why is that negative?
Oh, because
Is that
if this current is flowing that way with 1 amp, there's a voltage drop like this. Right? And that voltage drop in this direction is 3 times 1 amp. It's 3 volts. Right? So when you come Kirchhoff voltage law, okay, you have this voltage drop. Voltage drop must be equal to the voltage rise. If you go in this loop, okay, this is the voltage drop must be equal to the voltage rise
Okay.
that you find in the loop. So you have to count these two as voltage rises. Okay? Or you can also say that the total voltage drop is equal to 0. You can write Kirchhoff voltage law the other way too. Okay? So we are running out of time. So let's not do part B. 3 of part B is very trivial. Okay, I think most of you got it correctly, right? So let me do problem 4 because I only have 10 minutes left. So let's do 4a. Okay, 4a, in the circuit below, Vt is the capacitor voltage. Find the following. Okay, you have this circuit that does something like this, 5 amps, and then I have this 3 ohms resistor over here. I have this thing over here. Six ohms, and then 0.25 farad. Okay, you're asked to find this Vt. Okay, at t is equal to 0, you turn on the switch. Before t is equal to 0, that thing was set in that way for a long time. What happens to the capacitor? It will have discharge, right? So it will have 0 volts. So the first thing you know, okay, V0 minus is equal to V0 is equal to V0 plus must be equal to 0 volts. Okay, that is before you turn anything on. That has to be 0 because you only have the circuit on the right hand side before you turn anything on. Okay, then you ask to find V infinity. V infinity is the voltage after you turn on the switch. If you turn on the switch, then this becomes an open circuit, right? So after you turn on the switch, you just let it sit for infinite amount of time. This becomes an open circuit. The current would flow only through these 2 resistors. Okay, nothing flows through that resistor. So what is the current that goes through, say, the 3 ohm or the 6 ohm resistors? You can use current divider formula, or you can use parallel connection and combine them into one thing. If you use current divider formula, more current will go through the 3 ohm resistor. Okay, if you have current divider formula, you will have something like this. This is the current that goes through the 3 ohm resistor. Okay, and then times the 3 ohms is the V of infinity. Because you can calculate the current through any of the 2 branches and let that be the voltage at infinity, right? You find this current, I can use the current divider formula, find the current through there, and then multiply by the current through it. I would have this to be, what is 1/3 plus 1/6?
1/2.
Huh?
1/2.
1/2, right? So it's 1/2. So if you reciprocate this, you get V is equal to 2.
Times the current, right? Which is 5.
Let me see. This should be 5, right?
Yeah, it's multiplied by 5.
Multiplied by 5. Okay, because I have 5 amps divided by this formula over here. And then times 3. Times 3. Okay, because 3 is the voltage. The voltage, 3 times this will give me the voltage times 5 will give me infinity. So it's V is equal to 10, no, 15. That doesn't give me the right answer, right? So what did I do wrong here? Yeah, the 3 cancels. That's right, the 3 cancels and give me half. Half and give me 10. Okay, 10 volts. Okay? And then what is the time constant for this? Time constant is the RC time constant in this case. What is R? R would be the parallel connection of these 2. The parallel connection of this is 2 ohms, right? 2 ohms. And then plus 6, right? So R in total will be 2 plus 6, which is 8 ohms. Okay, R total. That the capacitor C's will be 2 ohms plus 6 ohms. And then the time constant tau should be 8 times 1/4. This is 1/4, which is 2 seconds. Okay? The time constant is 2 seconds. And then you're asked to write down V of t. You can write down V of t being equal to V of 0 minus V of infinity e to the minus t over tau plus V of infinity. Okay? And you all know this number. You just plug in. You get 10 of 1 minus e to the minus t over 2. Okay, that is V of t. And then you're asked to find zero input response. If there's no input, means you turn off the current. Okay, make it into an open circuit, then there's nothing that happens in the circuit, right? Everything is 0. So the third part, V0 input is equal to 0. Okay? And then there's this last part. You're asked to figure out the ODE for this circuit. And if you do the ODE for that circuit, then you can actually write down the Thevenin equivalent of this thing. Okay, this is an inductor, this is 2 ohms, this is 2 ohms, and then you can say that this is equivalent to the Norton equivalent. This current should be Vs over 2, this is 2, okay, and then this is 2, and then this is an inductor. Okay, this is 2 and 2 gives you 1. This gives you 1, and finally the equivalent one would be a voltage source. And then with a 1 ohm resistor and an inductor. Sorry, this is an inductor. Okay? So this is 1 ohm. And this inductor is 0.1 Henry. Okay, write down the ODE for this system over here. The ODE for this system you can memorize it from textbook, right? I can derive it using KBL. Or you can derive it, or you can say L di dt plus IR must be equal to Vs over 2. This is just KBL. You have di dt plus R over L I of dVs over 2 and 1 over L. Okay, R is equal to 1. L is equal to 0.1. So you get 10. You get this to be 10 I. And then this is L is equal to 0.1, right? 0.1 times 2. 0.2 is just 5 ES. Okay, so this is the ODE. Okay? Any question? Sorry I couldn't finish it because it's kind of long, right?